Reduced use of yellows. This subject was originally a reply to Peter Morris' Antir newsgroup thread, but I start a new thread here on the subject of DCom for others wondering about DCom. Questions and worries about problems with bold COM are heard in the newsgroups, and I here want to give some hints. First, I recommend to differ typical problems using a common CPU for serving multiple clients from the protocol, and related tricks, connecting clients to the CPU. More on that in the summary far below. Some screenshots visualizes some simpler solutions to some specific DCom UI component problem caused by bold components subscribing to individual fields of individual objects over a network, or even worse, over the Internet. Any transfer protocol will in a multi-user environment reach any present-day bandwidth limits trying to do so without care. But if used with care and designing the entire environment, server and client, to support a three-tier protocol solution, the bold DCom solution also has its benefits. Look at the screenshots below and try to imagine what's behind the scenes, remembering that no business logic exists on the client side, no logic exists in the database. It's all executed on one server CPU in interaction with multiple clients. It also shows that a RAD DCom UI doesn't have to be poor, 100% stateless, and dead to the user. In fact, it can be fairly populated and seemingly very active and responding to the user. With bold DCom you can decide the status of the data transferred between server and client. You can vary your approach and UI solutions depending on frequency of usage, the CPU load caused by single actions, and the need of active interaction and support of alternative data displayed. All this depending on details in user actions and changing contexts in edit dialogues, etc. Having this freedom, the keywords are very and possible concerning techniques. These keywords apply because you have an almost full range of technical and functional possibilities, although you don't always have unlimited capacity, bandwidth, etc. Thus you must vary your approach. Having said all this, reminding you of the fact that the form shown below is a fully functional in its final RT environment, DCom clients in MetaFrame, let's look at the screenshots. 3 screenshots showing data in viewers instead of displaying individual object members using separate DCom components for each attribute. Note also that most of the list handles are used only when triggering search operations on demand. They are normally fairly passive when only viewing and browsing data with the form, Fig 1, order book form, parcels for later transport planning, design time, the form looks fairly empty in design time, equals many blank HTML viewers Fig 2. In runtime the UI is fully informative and interactive. Clicking on the HTML viewer of the parcel details area opens a regular dialog with Delphi components, non-bold aware. On confirm the data is sent to the server, which inserts the details into appropriate object fields, causing the UI attribute parcel details as HTML to refresh the viewer by sending one single new HTML string back to the client. User messages are shown as errors, warnings, or information to the far right using symbols, client unique user language in HTML format text, or plain strings from code assertions or other code messages. Form captions and data labels are displayed in the language defined by the user. The same server function returns text in different languages depending on who is asking. Language can be changed in runtime, not fully implemented on this form though. You see both Swedish and English mixed here, plus some debug tools in the upper right corner for browsing and manipulating everything from bold class members to metadata, states, manipulating state transitions, traversing the current object structure, sending/receiving intra-client chat, ditto mail, and more. Shortly, everything. Note: this is called a thin DCom client. Fig 3. Here you can see the result of the previous dialog sent to the OSP and immediately parsed back to the client as one HTML string for the viewer, to the right of the new dialog below. A fast and simple concept. At last, Fig 3 shows an example of a regular HTML hyperlink triggering an event which determines which dialog and what data, since multiple parties are stacked in separate viewers to the left, to collect/to be displayed in the dialog. These fields are very special in that they are passive, displaying data, but at the same time actively capable of searching for data over DCom, and thus they are active on demand. But this activity has a relatively low frequency and they are very temporary and thus doesn't affect overall performance very much. Viewing and browsing data is what saturates the network. The hyperlinks are language sensitive before we fully implemented this on the client side, since the HTML text is generated by the OSP server and thus shown in my user language, Swedish. Summary: all the individual data fields shown in these examples were passive while visible. Yellow COM components were used only to retrieve chunks of grouped data fields as long strings and sent back again after dialogues were closed, except for the grid, which probably will be replaced later because this is a hotspot for Minitrix. Data validation is to 100% validated by business rules on the server side. No business logic exists in the client. With this approach of mixing concepts of active COM handles and passive HTML strings, the user experiences an active UI, but in technical terms it is almost stone dead. Nothing actually happens except for regular format checking in dialog fields and sending data back to server logic. The upside is that the yellow handlers are refreshing the viewers with the latest current HTML data using the regular bold subscription mechanism. Note that most subscriptions will be on the server side, since the HTML attribute keeps track of the multitude of fields internally on the server side, but only one field per viewer has subscriptions over DCom. Since the captions and labels in the HTML text are language sensitive, we have in effect many hundreds of pseudo-active data fields on this form. Seen from the server side, the viewer approach reduces that great number down to a fraction, and the UI is in effect not slow at all, even using a regular network connection. With many users, 10 plus, a MetaFrame solution would reduce network performance problems to nearly nothing. Server performance, perhaps one can get mixed up about performance problems with DCom, and the fact that a DCom solution implies using a common CPU as an application server. Note that the latter is related to the performance problem but not an explicit DCom problem. Efficient design and coding is a must for any solution using a common application server. Efficient coding alone is definitely not enough. Combining design and sharp coding will do, though. One must think efficient solutions/concepts starting from the very model and keep it for the overall design all the way back and forth to the clients. This is critical, and we learned a lot simply because we were forced to. We used a single common CPU on the app server side. Putting it all together, it don't look too bad with the bold DCom solution as far as I can see. Using it, being aware of its limits, bandwidth for detailed objects attributes, using tricks to reduce numerous objects in listings, etc., then it's all about you. It's powerful if used with care. It's useless if the design and application is not adapted for it. Finally, when we started using the bold DCom technique, it was buggy and slow, and it was obvious that it was impossible to achieve the required performance and reliability. Being stubborn and a little crazy, and bold soft fixing bugs and some optimizations, and sweetening it all with a little patience, and solving fundamental problems already in the model, avoiding coding tricks, it looks completely different today. To me, it looks promising. A talented designer fixes any bottlenecks and any typical performance problems in one way or another. new thoughts and never seen before solutions are sometimes, often, required, but isn't that what designers are good for anyway? The model is the system applies for bold COM2. Systems with many users would benefit from running clients in a meta-frame environment. // Lampa, current mail address, rolf.lampa@trilnet.com